Before viewing video lessons, it is important to read the textbook using the learning guide as your turn-by-turn directions. Then use the learning guide to take organized notes in your own words with examples and pictures.
But now we're going to move on to talking about sleep. Before we talk about sleep disorders, I need to talk about just sleep in general. This is a little refresher of what you learned in Gen Psych. So everybody in Gen Psych had the chapter on consciousness and sleep, right? We're going to refresh that. Our sleep-wake cycle is governed by the circadian rhythm. Inside your cells are clocks. There are biological timing mechanisms at a cellular level inside the body. And they regulate the functioning of the body. Now, these clocks get set by light from the external environment. And when I say light here, I'm specifically talking about sunlight, blue wavelength sunlight, natural light. So what happens is the light hits the retina. The retina is at the back of the eye. And there are cells on the back of the eye that are specifically designed to sense light. They don't see, they don't help you focus. The only thing they do, these photosensitive cells, is sense light and dark levels. That signal goes straight from the retina via the optic nerve. So the eyes sort of connect to this optic nerve that goes into the brain. And it's going to go to a part of the hypothalamus called the suprachiasmatic nucleus. And this part of the brain basically says, light, dark, light, dark, light, dark. That's all it's kind of registering. That's its main function, is to understand what's going on. Now, the hypothalamus, this specific part, but the hypothalamus can tell the endocrine system what to do. It sends information to the endocrine system. In this case, the suprachiasmatic nucleus sends a message to the pineal gland. There are two glands up in your brain. One is the pituitary gland. We talked about that when we talked about stress, right? The other is the pineal gland. So it's right up there, right beside the hypothalamus. So the hypothalamus is going to say, it's bright out, it's daytime. It's dark out, it's night. It's bright out, it's daytime. It's going to tell this part. And what the pineal gland does is it secretes hormones, because that's what glands do. In this case, the hormone melatonin. So if the pineal gland gets a message that it's high noon, the sun is shining high up in the sky, the melatonin doesn't come. If it gets the message that the sun has gone down and it's dark, then it secretes the melatonin. And the melatonin is what goes into our cells in our body, and our body kind of knows. It's daytime, it's nighttime, we sleep at night, we're awake during the day. Now, light is one of the biggest things that sets that circadian rhythm. There are a few other things though. Activity level. When are we supposed to be active and moving around? Daytime, when the sun is up and where I can see danger, and where it's easier for me to find food from an evolutionary standpoint. At night, when it's dark and there's scary things in the dark and I can't see those scary things very well, what should I do? I should just kind of sit here and not move, right? It's a great time to rest and restore. And so if you're super active at night, physically active, mentally active, your circadian rhythm is going to go, what? Are we supposed to be awake now? I'm getting mixed messages here. The body is doing Zumba, right? And the light level outside is telling me that it's supposed to be sleepy time. And so the circadian rhythm is going to be like, we don't know what to do. We don't know what to do. Getting mixed messages. Eating also affects the circadian rhythm. So at night when you're sleeping, for this extended period of time, you don't eat. You fast every night. And when you wake up in the morning, what are you supposed to do? You're supposed to break the fast by eating something first thing in the morning. If you get up in the morning and you don't eat anything, your circadian rhythm is like, I don't know. I'm not sure we're awake. And so the clock is going to get out of whack. The other thing that's really important is the circadian rhythm is kind of like a really sensitive cuckoo clock. Anybody have a relative that had a cuckoo clock? Did you always just want to go over and pull on the chains? Like it just begged to be pulled on, those stupid chains. My great aunt had a cuckoo clock and I just, impulse control. I just want to touch it. But you don't touch it because it's very sensitive, right? So she was constantly setting that clock. Your circadian rhythm is set every day. So it's set with regular patterns of light, activity, and eating, going to sleep and waking up at roughly the same time every day. If you do that, your clock is like, yep, everything's happening on time. This is 15 minutes earlier, this is 15 minutes later, but we're pretty much on the same pattern and that clock's gonna function really well. If, on the other hand, those three things are swinging drastically from one day to the next, the clock is going to get messed up. Now, the other thing that we need to talk about is what happens when you sleep. So again, this is a little refresh from Gen Psych. Now, right now, you guys are all awake and alert. I think you at home are awake and alert, but I can't see you. So I assume you're awake and alert. You guys are having beta brainwaves right now. Beta brainwaves are where you're trying to solve a problem of what the heck is she talking about and is this meaningful to me, right? So right now you're in beta. Before you can go to sleep, your brainwaves need to be in alpha. That sleepy, daydreamy, zombie kind of way of being. If you're in that state of sleepy wakefulness and you lay down in bed, within about 10 minutes, you should drift off to sleep. You're going to go into stage 1 sleep, which is where you transition from alpha to theta brainwaves. Theta is light sleep. This stage of sleep, you are easily startled awake. So you sometimes, you just falling asleep and any little thing will wake you right up. That's stage 1. As a part of this, it's normal to have a little jerk sometimes. And so sometimes you might even like twitch and jerk yourself awake. So stage 1, it's that drifting from alpha into theta. And you sit there for about 10 to 15 minutes. Then you're going to go through a transition stage, stage 2, which is going to be primarily theta waves. But inside those theta waves are going to be what are called sleep spindles. So in the EEG, this is a pattern of super frequent, bunched up together, little things on the EEG patterns. And then there's also these patterns that are called K complexes that look kind of like a K, because you got one swing up and one tail down. And that's essentially a transitory stage, going from stage 1 down to deep, slow wave sleep. Now, sometimes this is categorized as just stage 3. Other times, as in this picture, you see it as stage 3 and 4. But essentially, this is delta sleep. Delta sleep is high and low waves, very deep waves on the EEG pattern, and they're slow in frequency. We also know that there is a swishing of fluids in the brain now during this deep, slow wave sleep. And this swishing of the fluid in the brain is sometimes characterized like a dishwasher. We're kind of washing the brain. Part of what's happening in this stage is we're sort of cleaning out all the accumulated waste products in the water. And there's this swoosh, swoosh, swoosh while you're sleeping. You're going to spend quite a bit of time down in that deep slow wave in your first cycle. And then you cycle back up. And you're going to go back through the sleep spindles. And then when you get to the tip top, you're going to enter REM sleep, rapid eye movement sleep. And this is the sleep that's most associated with dreaming. The first cycle of the night, you're only going to spend a couple of minutes in REM. And then you're going to cycle back down to deep slow wave, but you're going to spend less time this time around in deep slow wave. And as you cycle back up, throughout the night, your REM time gets longer and your deep slow wave gets smaller until by the end of a night, you're not even going down into the deep stages anymore. And these cycles are about every 90 minutes, you're cycling. Now, it's also common for people to wake up. They're most likely to wake up when they're in these lighter phases here, right? Less likely to wake up in that deep slow wave phase. And that's normal, a couple of awakenings. And most of the time, the awakenings, you don't even really remember. You know, you hear a noise and you kind of wake up and then you turn over and you're back to sleep. Or, you know, you're cold and so you steal the covers and then you go back to sleep. Or you're hot and you fling the covers out, you know, so you don't even really fully wake up. You just slightly wake up. So this is really important to refresh yourself on before we talk about the disorders, because you need to know what normal sleep is supposed to be like before we talk about disordered sleep. So a couple of other things about sleep I want to make sure we hit today. How much sleep do you need? Well, it's going to vary for every one of us. Each one of us has unique sleep needs, and those needs change across the lifespan. Newborn babies, for example, sleep 16 hours a day, but for only about an hour and a half at a time. So little chunks of sleep. And they typically eat, sleep, poop, change the diaper, eat, sleep, poop, change the diaper. Like that's their pattern at first. 50% of a newborn's sleep is in REM, rapid eye movement sleep. Our sleep as adults is somewhere between 17 to 20% of our time of sleep is in REM. As an adult, 7 to 8-ish hours is recommended. But you may be more 7, you may be more 8. If you're stressed, you might need more sleep. If you're sick, you might need more sleep. If you've done some intense physical activity, you might need more sleep, right? So even how much sleep you need tonight might be varied based on what you did that day. So there's no magic number of the amount of sleep that you need to be healthy, but we know generally speaking, adults it's 7 to 8. We also know that sleep impacts everything. Your physical health, your ability to think. When you lose sleep, you are literally dumber the next day. You have cognitive deficits when you miss sleep. And we know that sleep affects our mood. Who is a grouchy bear when they have not slept well? I'm short-tempered. I'm much less patient with the world if I don't sleep well. And I'm speaking from experience today. My daughter woke up at 3 o'clock in the morning. So I'm like, darn it. Not a great night of sleep for me last night. Um, Now, the other thing that's going to be complicated when we talk about sleep-wake disorders is having poor sleep, having disruptive sleep can be a problem by itself, but having bad sleep can cause other things. So having bad sleep could cause a heart problem. Having bad sleep could cause depression, right? Could cause weight gain, which then is related to heart. There's all these kinds of factors. The other thing is other problems can cause a sleep problem. So being depressed can disrupt your sleep. Having heart problems can disrupt your sleep. Being overweight can disrupt your sleep. So sometimes when we look at these disorders, it really becomes which of these conditions came first. And sometimes we just don't know, but we know both of these things are happening at the same time. Another big concern we have is a risk for accidents. Because remember I said if you're not sleeping well, you have a cognitive deficit. It's similar to driving while intoxicated. So when we test you on all different kinds of cognitive tests, if you're sleep deprived, you test kind of like a drunk person. It also impacts your ability to learn the next day. So if you don't pay attention, you can't learn. If I'm sleepy, I have a hard time focusing. So I'm not going to learn much that day. If you don't sleep, it impairs your memory. Everything you did today, everything you learned, everything you were exposed to, everything you thought about today, at night when you're sleeping and go through REM, those memories get rehearsed, refreshed, those neurons fire, and they wire that experience into your memory. If you don't sleep tonight, you might as well have not come to class, because those memories are not going to stick. A whole lot of that is going to get washed out in the rinse cycle of the brain. Because if you don't use those connections, they get lost. So you worked really hard today to create this memory. You want it to stick. You've got to sleep. The other big thing that gets inhibited is neurogenesis, and this is part of why memories don't stick. Neurogenesis is the creation and the maintenance of creations of connections between neurons. You literally grow dendrites and axons out to each other from the neurons, and they reach out and they form these connections, and that's how a memory is formed. If you don't sleep, that doesn't happen. That's my 2-minute warning. We also have like a rough statistic. If you're sleeping too little, less than 5 hours, you have an increased risk of death, mainly due to accidents. Heart attacks is another common cause of death. If you're sleeping too much, more than 9 hours, it's also associated with an increased risk of death. In this case, we think it's a largely correlational relationship. If you're sleeping more than 9 hours a day, chances are you're sleeping more because you have a physical health issue. You're sick. So think about when you have the flu. You sleep a lot, okay? Probably the sleep itself didn't directly kill you. It's the other health issue that's causing the death. But we do see that correlational relationship. So last two things I want to mention here. We only diagnose a sleep-wake disorder if the symptoms warrant independent attention. So maybe they have heart disease, maybe they have cancer, maybe they have depression. If their sleep is so bad that we need to focus on it as a treatment goal, then we're going to add that disorder diagnosis.